Uno más los muchachos. Okay, last problem, 10th problem in our thermodynamic and last problem in the thermodynamic unit. This problem is also using the delta G equation. We'll see why in just a second. I put an equation up here that we're going to need for that last problem. It says carbon monoxide and chlorine make a gas called phosgene gas, very poisonous, nasty gas. Let's go ahead and see what we got in this last problem. Last problem says the equilibrium constant Kp for this reaction. So we're given the Kp, all gases, Kp, for this reaction. We're given that value is 5.62 times 10 to the 35th. 35th is a huge number for K. We all remember that means this really wants to form this gas here to the right. Spontaneity, people. Calculate the delta G, ready, of formation. It wants the delta G of formation, not the delta G of the reaction here. We're trying to find the delta G of formation for the phosgene, okay, standard conditions. So what that says is we need to find out the delta G of F for this. If you go and look up the delta G F for that in the back of a chemistry book, most chemistry books aren't going to have it. It's not a very common thing, so they usually has commonly things. We can look at it, I mean, we could find it online, sure, but we're going to figure out what it is. Now, how are we going to do that? Okay, so I know that the delta G of a reaction is equal to the sum of the products. There's only one product here, and there are no coefficients in front, so the sum of the products. This. So, well, wait a minute. I don't know what the delta GF of that is. In fact, that's what we're trying to find. You see, we're trying to find the delta G for that product. Products before reactants. So sum of the products, which is only one, X, I don't know what it is, minus the sum of the reactants. So we have two reactants here. Let's add up their G values. Well, the G value of chlorine, elemental chlorine, is 0. So the G value of the carbon monoxide, look it up in the back of the book, that's common, it would be there, but don't worry, I got you. Remember, I'm here for you. I have looked it up for you. We have the delta G of formation for carbon monoxide is negative 137.3, so minus 137.3, right, did I get that right? 137, yeah, kilojoules per mole. So we can go ahead and now solve for X, okay? We're gonna, oh, wait a minute, no, we can't. We can't solve for X because we don't know the delta G of the reaction. Well, how am I going to get the delta G of the reaction? We usually take products minus reactants and we figure that out. But I can't figure it out because I don't know it and I don't know that. And that's why it's still up here. We're going to use this equation. The delta G this way or the delta G this way, it doesn't matter. They both calculate the delta G of a reaction. So in this case, delta G of the reaction, as long as we have R, which we know is 8.31. So I'm going to put negative 8.31 here, times the temperature, which we said was standard temperature, that's 25. Kelvin, we add 273, 298. Times the natural log of K. Now K was given as 5.62 times 10 to the 35th. 5.62 times 10 to the 35th. Okay, there's my setup. I can figure out what the delta G of this reaction is. Then once I have the delta G of the reaction, using my delta G equation with the natural log in it, I can go ahead and put that right here. Solve for X. Piece of cake. All right, so let's go ahead and do that out. So I'm going to do natural log first. Natural log. Where is it? There it is. ln 5.6. ln 5.62, second function 35 equals 82.3 times 298 times 8.31. And I get this big, big number. And it's a negative too. Don't forget the negative doesn't go away. It's still there. So what I end up getting for this heat of the reaction, is I get a negative 20384, and this round is 848. So I'll round that to 848. So 203,000 plus. Remember in the last problem we had you convert this delta G, which we were given in the last problem, to joules, and that's because this is based on joules. So I use joules here. So when I calculate G using R, then I'm going to get joules. So this number is in joules. That's why it's so big, is in joules, not kilojoules. And these, remember, your heats of reactions are in kilojoules per mole. So that means I convert this to kilojoules. So 203.8, well, I'll make that 0.9. Well, I'm gonna round it up. Negative 203.9, and that's in kilojoules per mole. This is given in kilojoules per mole. Yeah, it's there. Go ahead, check it. Kilojoules per mole. So now I'm ready to go ahead and solve for X, which will now be the heat of formation of the phosgene. So go ahead and do that. This is subtracting a negative, so that's really adding it. Then you get X, we'll subtract 137, so minus 137.3. Okay, do the math on that. So negative, but you're subtracting from a negative. So negative minus a negative makes it more negative. So what you're really doing is you're adding these together to get a big negative number. So this negative minus that is going to be a negative, let's see, 9, 10, 12, 10, 11, 4, 3, negative kilojoules per mole. So we should get negative 341.2. Bam, nailed it. Negative 341.2. You see it, yes. So we have the answer. It looks like it makes sense. The K value is very big, which means it wants to go in this direction. We got a delta G for the reaction of a negative. That means it's spontaneous in that direction. And then we were able to use that and calculate our delta G value for the formation of this, which should be negative because it wants to go that way. So remember, we get a negative value for delta G. It tells us absolutely that that is a spontaneous reaction. So this value is the heat of formation, delta G of formation for, where'd it go? Right there, for you. So if you were to look that up, and don't believe me, I mean, you know, you wouldn't want to believe the guy wearing this kind of shirt. So go ahead and Google that. Find out what the delta G of formation under standard conditions is for phosgene gas. You're going to find it to be that. All right. That ends up the thermodynamics unit, the problems that we need to solve. Whew, a lot of them this week, but don't worry. We're done with thermo, a little electrochemistry, and we will be all done with the whole course. I don't cry, Satchel, you should, so